we now have a list, but you'll notice here it's got this new line character in it as well, which is a little bit problematic. We've got everything in list form, which is great. A list is mutable. We can change it around, we can edit it, but we've got this new line character at the end. Now, whether or not that is a problem, well, let's see if we can do a few other things. It is now in list format, so we can take that list, which is the list of hex values, and we can perform a couple of operations on it. One of them is the remove function. So we can remove an empty line as well. We've got an empty string here. So this is a list of individual strings that we've made from our big string that we've imported. So if we remove the blank string and then run this again, well, I'm not going to run it again twice. I'm just going to shift it down like so. And now we can see that it has indeed removed that beginning empty string. That would cause us a problem otherwise, because that string itself wouldn't contain any information. And then the other thing we should need to remove here, we could remove the /n. I'm not sure whether that works. It's a special character. It's the new line character.
I would actually split on the /n and remove the hash.
Well, the hash is already removed.
Right. I'm just interested that you went that way around.
Yeah, well, let's try that. That's a great bit of feedback there. And let's see if we need to comment.
Sorry,
out
I don't
that
mean
line.
to be
No. I like it because it's a great way of looking at it from different ways. So yes, we could split, and then we can remove the hash. Or indeed, we wouldn't have to do that at all, because what we can do, and we'll be splitting using indices in a moment, but just for the clarity of cleaning everything up, it says that's not in the list. I think what we'd have to do is a for loop in order to do that, because we need to go through each string that's within the list and remove the hash from it.
Or you could take the string, assuming that, okay, so this is where sanitizing becomes interesting, because if we're doing it my way around, if we assume every line begins with a hash, so we would have to remove the blank data first.
Yeah.
You could just remove the first character from that string.
Yes, and we can do that very, very easily as we loop around. In fact, it's you could argue that if all of your information coming in is always in the same format, then what we can do is just loop round each one of these particular strings and just take the second and third, the fourth and the fifth. And I think that's what we'll do in this particular case to make sure we don't need to remove it. We just don't reference it.
Mm-hmm.
So what we need to do is go through each one of these. So our variable in this for loop, we could call it a character. We could call it a value. I'm going to call it a value in this case. In our list of hex values, we're going to do the following. We're going to print out the value. We're going to make sure that we know what we're handling. I always do this whenever I'm going through any of my code. I want it to come out, and yes, it's printing out the value for each one of these. Now, what we can do here, I hope, is we can use square brackets in order to do some string slicing. So then we can go from 0 to the third. And let's see what we get if we go ahead and print that out. So here we've got 8.2 as the beginning and 8.2 as the beginning. So what we can do here is, instead of from 0 to 3, we can go 1 to 3. And that's actually printing out the red value of our string, 82. That's in hex. That's not 82 in decimal. And we'll be dealing with that in a few moments. So we know what we're getting out here. So I'm going to remove the print. And in this particular case, I'm going to use shorthand here. I'm going to go red equals this value here. And then we've got green equals. And again, we're going to look at the same place. And this time we're going to go from 3 to 5. Now you'll notice here it's picked up not 0, 1 and 2 are there. And then the third one is not included. That's just the way that this syntax works. And then finally, we've got our blue here, which will be value. Great typing, Mike. Value between 5 and 7. And then finally, we can do a quick test. We can print out R, G, and B. And what we should get here is each one of the values that we had before. So 82, 78, and 78, 7B and 85. If we go up here, yes, it matches that. Brilliant. Now, I don't want to have to keep scrolling up and down. I've left it, usually I sort this out much earlier on. I don't want to have to keep scrolling up and down. It's a real pain in the butt. And once you start to get a lot of the things that are similar, it can be really difficult to diagnose. So I want to reset the console each time I press play. So I only have fresh information. So I'm going to go right up to the top of my editor window here, and I'm going to import a module or two. I'm going to import OS, which is going to allow me to clear that screen. And I'm also, whilst I'm here, I'm going to import BPY. Later on, we're going to be interfacing directly with Blender, so we need the Blender Python module. Right, down here, I'm going to clear the screen. So I'm going to go os.system, open brackets, CLS. And that's going to clear this. Every time we run it, it'll just be that information there, which is really, really useful and saves us having to scroll up and down or potentially getting lost, which would be really, really annoying. So what we've got to do here is now put these in a range that Blender actually understands, and it needs to be in the range 0 to 1. So first of all, we need to change these from hexadecimal, which is base 16, to base 10. So if we go in here, and again, this is one of the places where you could be more optimal and chunk everything all the way up the top here. I'm not. I'm going to do the operation on each one individually, and I think that's easier to read as we're following along at the moment. So I'm going to take the value R, and what we can do here is the integer method here is going to take in R as a value, and we need to tell it it's base 16. So we can type in base equals 16. That's not entirely necessary. What we can do is just comma 16. And now when we go ahead and press play, it's converted the number we had before into 130, which will be a value because it's 8-bit values between 0 and 255, which is that 2 to the power 8, 8-bit? I think so. So what we can do here now is do the green value is going to be the int, and then we pipe in G again, comma 16. You don't have to type that base in. And then finally the same again, int B, comma 16.
A question from Jenny. Is it safe to assume that someone would have to indicate which operating system this program is for if they have the OS commands in it?
If you implement them correctly, yes. You can code in a way that's system agnostic. So OS system, this particular command here would clear the system console on any machine. However, if you're opening files from specific directories on machines, you can end up being in a position where, so for instance, there's no such thing as a home directory on Windows, really. And your username, you can't just say go to the user directory and do X, Y, and Z like you can on Linux and Mac. You would have to specifically code in either a hard code, or indeed there is a way of doing it that's beyond my technical expertise, because you actually go into the Windows registry in order to find where that place is on someone's hard drive. The problem is with Windows, or the challenges with Windows, that your user directory, you can remap to anywhere you like. And I'm sure you can do that on Linux and Mac as well. But you can actually just put your documents on your E drive, and then you can put your pictures on this drive. It's quite flexible, but it does actually come up with some issues. And obviously the code I'm writing here will specifically work on Windows because it's working on my machine, but it won't necessarily work exactly on Linux or Mac. We haven't touched any of the bits yet that wouldn't work. And I think we might hit them later on, but we're going to be very literal. We're not going to code something in where you're clicking a button and navigating to a file. We'll be opening literally a literal place on the hard drive, which case you just put your own path in instead.